Okay, welcome back to our channel Thermal Properties of Matter Part 3. Part 3 we have to learn yesterday classes expansion of solids and scales, different types of scales. Now we have to take the examples and relation also. Alpha is to beta is to gamma is equals to 1 is to 2 is to 3. Next we have to now learn the examples of the expansion of solids. Let's go. Expansion of solids examples. First of all, a material in a semicircle. Okay, in a semicircle. A material in a semicircle. Material in a semicircle manner. First, what is this? A material as a copper. Suppose we are thinking this is a copper or any. Now let's take a point of object A to object B. Point A and point B. Length L. Then this radius is R and diameter is 2R. Diameter is equals to 2R. Okay, next the new distance between the points A and B. New distance between the points A and B. Okay, now the diameter is 2R. Semi. The material is copper. The distance between the A and B is equals to length L kada. A and B length L. L dash is equals to L into 1 plus L alpha into delta T. This is the length. L dash length. Okay. Final diameter D dash is equals to D of 1 plus alpha into delta T. D of 1 plus alpha delta T. Okay. Next, this is a one example. What is this? Semicircle, a material like example is copper. Points A and B, distance is L, radius is R, diameter is 2R. Next, the new distance between the points is L dash is equals to L of 1 plus alpha delta T. Final diameter D is equals to D dash is equals to D of 1 plus alpha delta T. Is first example completed. Next, second example is disc. This is a disc. In a disc, point A and point B. What is this disc? Next, in the disc, small cavity is this. Distance R. This distance is L. Okay. Radius is R. Distance is L. Okay. Now, same. Heat supply. Heat supply. Heat supply. Heat supply. When heat supplied, the cavity expands uniformly isotropically in all directions. The cavity expands uniformly isotropically in all directions. Uniformly expands isotropically in all directions. This is a cavity. Expands in a uniformly isotropically in all directions. Then the length L dash is equals to L of 1 plus alpha delta T. Next, area. This is area is equals to A dash is equals to A of 1 plus beta delta T. Beta delta T. Next, initially is a sphere. Disk means sphere. Sphere circumference is pi square. A dash is equals to question mark. Then final area. A dash is equals to A of 1 plus beta delta T. Then beta is also known as A dash is equals to A of 1 plus 2 alpha delta T. It is the final. A dash is equals to A of 1 plus 2 alpha delta T. Okay. Next, take an example of 3. Okay. First, I will explain once again this. This is a disk, point A and point B, distance L, and is a cavity. Radius is R. Small cavity, radius is R. Heat supplies. When heat supplies, cavities expands uniformly isotropically in all directions. Okay, length L dash is equals to A L of 1 plus alpha delta T. Then area A dash is equals to. Then initially this one sphere circumference, this one. A dash is equals to final area. A dash is equals to A of 1 plus beta delta T. Beta is equals to 2 alpha. Okay, or you understand? Next one, third example, the wire. Third example is wire. Distance L, acting tensile force. It's a wire rigidly fixed between the 2 points. Tensile force inside the string. Next, if delta T change in temperature increases, positive. Temperature decreases, it's negative. Temperature increases, positive. Temperature decreases, negative. Next, delta L is equals to alpha L into delta T. Alpha L into delta T is the first L. Change in L. Okay, change in L. Next, modulus, Young's modulus is equals to stress. Young's modulus is equals to stress, and Young's modulus is equals to stress by strain. Young's modulus is equals to stress by strain. That stress is equals to F by A by delta L by L. Then we written as this one. After completion of this, right, right, F by A is equals to delta L by L, Young's modulus, that is equals to alpha delta T Young's modulus. F is equals to Young's modulus alpha delta T into area. length increases, whereas length increases, flattens and loosely fitted. Length increases, flattened and loosely fitted. Okay, this is a final formula. Force. Next, fourth one, the sphere and small cavity, radius r, small cavity in the sphere. Volume increases. If the volume is increases, V is equals to 4 by 3 pi r square. Volume increases. It is a photographical enlargement. It is a photographical enlargement. Okay, V dash. Finally, V dash is equals to 4 by 3 pi r cube into 1 plus 3 alpha delta t is a final volume. Next example is rod. Fifth example, a rod. A rod expands. Delta T, temperature increases. N is equals to normal reaction. That also is equals to thermal stress. Then N is equals to Young's modulus alpha delta T into area. Young's modulus alpha delta T into area is a final formula. Now let's go to example. Time period. Take a question. Time period is a question in a JEE mains. Time period for pendulum clock. Time period is 2 seconds. In a pendulum clock, time period is 2 seconds. Okay, in a pendulum clock, time period. This is a rigid support. Time period is 2 seconds. Okay, now temperature increases in summer. Temperature increases. Time period is increases. Clock runs slow. Clock runs slow is a main key point. In winter temperature delta T. Temperature decreases, time period decreases. Then clock runs fast. It loses a time. It loses time. It gains time. Okay, I will explain in a brief manner. Time period of a pendulum clock. This is a pendulum clock, regular pendulum clock, 2 seconds, whose time period is 2 seconds. In summer, temperature increases, time period also increases. Clock runs slow. It loses a time. Then temperature decreases in a winter. Temperature decreases, time period also decreases. Clock runs fast. It gains time. It loses the time. Okay, then from SHM, T is equals to 2 pi under root of L by G. T is equals to 2 pi under root of L by G. Okay, T dash, final time period. 2 pi under root of L dash by G. 2 dash under root of L by G. Next, T dash is equals to 2 pi and the root of L dash means L of 1 plus alpha delta T by G, that is equals to 2 pi and the root of L by G 1 plus alpha delta T whole power 1 by 2. Okay, delta T whole power 1 by 2. Okay, from a binomial expansion, from binomial expansion, del T dash is equals to T of 1 plus half alpha delta theta. Then delta T by T is equals to half alpha into delta theta. Okay. Okay, we will see in the next class.